everyone, and this is Q5 matrix multiplication. Yesterday we looked at what a matrix is and some of the attributes of a matrix, for example, the rows and the columns. And now today we're going to look at multiplying two matrices together, not just a scalar, not just distributing a number into all of the items, but we're actually going to be multiplying two matrices. So in this slide we have an example of matrix multiplication, and I'd like you to just maybe pause for a moment and think about what the rule might be. Now notice our little meme here. Sometimes you got to run before you can walk. So we're going to look at what matrix multiplication is all about and how it works. So let's go on. So we've mastered scalar multiplication. That's just multiplying or distributing in a value. But now we're going to look at matrix multiplication. And before we actually get to multiplying the matrices, we want to look at the size or the dimensions of what I'm multiplying, because the dimensions have to be just so for the multiplication to work. So in this case, I have an example of taking a 3 by 2 matrix and multiplying it with a 2 by 1 matrix. Now this works. This is an example of two matrices that could be multiplied together because these two in the middle have to be equal, the same dimensions. If the number of columns in your first matrix is equal to the number of rows in your second matrix, then yes, it is possible to multiply them. And the resultant matrix, your answer, the dimensions of your answer are going to come as a result of the outer side. So my answer to this is going to have 3 rows and 1 column. Or in other words, this is going to be a 3 by 1 answer. So let's just make sure we get an understanding about the dimensions before we move on. Is it possible to multiply a 2 by 3 matrix with a 3 by 5 matrix? And as long as these values are equal, then it is possible. And the size of the answer or the resultant matrix will be a 2 by 5. In the second example here, a 2 by 2 matrix multiplied by a 3 by 2 matrix, is it possible to do that? And the answer is no. It's impossible to multiply those dimensions together, which is one example here where you can see that matrix multiplication is not commutative, because if I flip the order of my multiplication, the 3 by 2 times a 2 by 2, that one I could do, and my answer would be another 3 by 2 matrix. So matrix multiplication is not necessarily commutative, meaning I can change the order. All right, so I'll give you a minute to jot down this example, and we're actually going to get to how do you come up with the answer, the resultant matrix. So first of all, it's important to find the dimensions or the size of what the answer is going to be. So I'm going to do that up here. My first matrix has 3 rows by 2 columns, and I want to multiply that with something that is 2 rows and by 1 column. So it's possible to multiply them because those middle values are the same. And so my resultant matrix is going to be a 3 by 1. So that means I'm going to set up the size of my answer. I'm going to have 3 rows and 1 column. Okay, now how do I actually find the pieces in there? So we always want to remember that we get the rows from the first matrix and the column of the second. So I'm always going to go across the rows and down the column. Now, to the numeric part, I'm going to take 5 across the first row. I'm going to take 5 times -2, which is going to be, let's just go right to -10. And then I'm going to add to that 3 times 3. Remember, I'm going across the row and down the column. So 3 times 3 is 9. And so the element in row 1, column 1 is going to be -1. If I think about filling in the next item, this is now row 2, column 1 in my answer. So this tells me to use row 2 and go down column 1. So I'm going to go back to my matrices that I'm multiplying together, and I'm going to go across row 2 and down column 1. And I'm going to multiply, add, multiply. So let's multiply -1 times -2, that's +2, plus I'm going to add 2 times 3, which is 6, and so 2 plus 6 makes 8. Finally, the last one, I'm going to change colors here just so we don't get confused. So I always go back to my answer and think about the address for what I'm trying to fill in. So the address here is the third row, so row 3, and it's column 1. So I'm going to go across row 3 for my first matrix, and I'm going to go down column 1 with my second, and I'm going to multiply, add, multiply. So going across the row, I have -4 times -2 on the column, that's +8, plus I'm going to have 0 times 3, that's 0, so it's going to be +8. So my resultant matrix from multiplying these two together is going to be the matrix -1, 8, 8. Okay, moving on. Whoa, let's go back. Find the product of the matrices if possible. So we always want to start off by finding the size or the dimension of the resultant matrix. And if I have a 2 by 2 multiplied with another 2 by 2, yes, I would say these are possible to multiply together, and my answer is going to be yet another 2 by 2. So I'm going to set up a matrix with 2 rows and 2 columns. So I think about filling in, let's fill in this first row, first column. So I always take the rows from the first matrix and the columns from the second. So I'm going to go across the row and down the column, and I'm going to multiply, plus I'm going to multiply. So I'm going to have 4 times 5 is 20, plus -1 times -3 is +3, so that item is 23. If I want to jump across and fill in this element right here, now this is row 1, column 2. So I'm going to go across row 1 yet, but now I'm going to go down column 2, and I'm going to multiply. 4 times 0 is 0, plus -3 times 3 is -9, so this is going to be -9. If I jump down here, I'm trying to fill in row 2, column 1, so I'm going to go across row 2, and I'm going to go down column 1. Think about the address that I'm filling in, row 2, column 1. So I go across row 2, down column 1, 2 times 5 is 10, plus 1 times -1 is -1, this would be +9. Finally, the last element is row 2, and it's column 2. So I'm going across row 2, and I'm going to go down column 2, and I'm going to multiply. 2 times 0 is 0, plus 1 times 3 is 3. So there is my resultant matrix. Okay, if I look at this one, I want to find the size of the resultant matrix. So I have 3 rows by 1 column for the first matrix, and then I want to multiply it by a 1 by 2. So yes, it's possible, and my answer is going to be a 3 by 2 matrix. So this would have 3 rows and 2 columns. Now, why don't you pause the video and see if, well, actually, see if you can't fill in these elements. So I'm going across row 1, down column 1. So all I have is 5 times 2, which is 10. If I go across row 2, down column 1, row 2, column 1 would go right there. That's 12. And row 3, column 1 is negative 4. If I switch now, I'm going row 1, column 2. So across row 1, down column 2, I've got negative 20. And then I've got negative 24. And I've got positive 8. This time I look at the size of my matrix that I'm multiplying together, my matrices, and I start with a 2 by 2, 2 rows and 2 columns. And I want to multiply it with 3 rows by 2 columns. And is this possible to multiply together? And the answer is no. The dimensions of these 2 matrices, it's impossible. Nice spelling. I can't think and talk and write all at the same time. It's impossible to multiply them together because of the dimensions. This time, solving for x. So now I've got a matrix multiplication problem, and I want to know what number had to be right there in place of the x. And so if we think about it, I know I'm going to have to go down this column because it's the only column there. And I can really think about this. I mean, let's go over here. I know this answer is negative 2. So this was the result of multiplying across row 1 and down column 1. So why don't I try going across row 1 and down column 1, because I know that answer has to be negative 2. So that means I took negative 2 times 3, so that's negative 6, plus 1 times x is x, plus 2 times 1 is 2, and that has to equal negative 2. So that allows us, just looking at what the multiplication would be, that allows us to solve for x. So if I just combine like terms, I get negative 4 plus x is negative 2, and then add 4 to both sides. So x would have to be 2. It's not the only way I could have done that one, because I also know what row 2 column 1 is. I could have made up an equation based on row 2 and down column 1 and made it equal to 17, and I would arrive at the same answer. Okay. Now if I think about solving for y on the other hand, because y is row 3 column 1, I would have to go across row 3 and down column 1 to set up my matrix equation. So I'd have negative 2 times 0, which is 0, minus 34 plus 4y is, not that, plus negative 2 times x is negative 2x. So 0, I'm going across this row and down this column. So 0 times 3 is 0, minus 2 times x, plus 4 times 1 equals y. And because I know the value of x, I could plug that in and find the value of y. All right, last thing here. This one is for all of you that work at Bricks. So the football team is stopping at Bricks for a post-game treat. They may choose from $3 pound cones, $5 flurries, and $4.50 shakes. And we have 35 players choosing a cone, 40 choosing a flurry, and 12 choosing a shake. Now we want to figure out, by setting up a matrix multiplication equation, to find the total amount due at Bricks. Okay? So think about what we want the answer of our matrix multiplication to be. We just want to know one thing. We just want to know the total. So this means we want the resultant matrix to be 1 by 1. Which means when I go to multiply them, I'm going to have 1 times something times, this has to be the same something, so I can multiply them together by 1. Well, because I have 3 choices, a cone, a flurry, and a shake, I'm going to make a 1 by 3 and a 3 times a 3 by 1, so that my resultant matrix is a 1 by 1. Now, what order you put these in, I guess, really doesn't matter. If we think about how we would just calculate a total, I would think about multiplying how many I'm buying times the price for each item. And so let's see, let's make a 1 by 3 matrix. So I've got 1 row and I've got 3 columns. And then I want to multiply it with a 3 by 1. So I want 3 rows and 1 column. So if we set this up, we would probably want to put like the $3 pound cone. So this is going to be $3. And how many people are choosing the cone is 35. So this is like the player total. And this is the cost matrix for each one. And so we have $5 flurries, and we are choosing 40 of those. And we have 450 shakes, and we have 12 people choosing those. And if I do the matrix multiplication here, I'm filling in row 1, column 1. So I'm going across row 1, and I'm going down column 1. So I'm going to multiply 3 times 35 plus 5 times 40 plus 450 times 12, and that is going to be the total amount that I'm going to pay to Bricks. You can go ahead and figure out what that total is. Oh, and don't forget the tip for all those people that worked so hard there. So we'll be answering questions on matrix multiplication. Give your homework a good shot on Q5, and we'll be in class to answer questions. Bye-bye.